For example 3, I'm going to start off with a story. I want you to imagine that this Olympic-style swimming pool, we're going to imagine it doesn't say Chicago, imagine it says Rio. This Olympic-style pool starts to leak. And in my geniusness, I say, oh, here's a cone. I'm going to scoop out the water, and I can put it back in. So I'm going to collect the water inside of here. Not the most genius idea, but it's something that has occurred to me. Now, unfortunately, as you may have noticed, there's a hole at the bottom of the cone, so this is not really going to work very well. But in my geniusness, I've taken some chewing gum and put in this hole. It's still dripping water, but it'll work, okay, kind of. So I've got my pool, and here's my cone. Here's my diagram over here. I'm going to bring this guy over. Okay, so here's my cone. I'm going to go ahead and take this guy out. And my swimming pool. You guys can imagine the swimming pool. So here's my cone. I have the chewing gum in here, but water is still spilling out. It has a slant height of 10 inches and a radius of 6 inches. Now, while I'm scooping water back into the pool, trying to keep it full, I start to notice something about the water inside of the cone. And here's what I notice. Now, I'm going to have to bring this over. So hold on. Let me bring this guy over. Some notes. Okay, here's what I note. I notice that if I fill up my cone at 12 p.m., so at noon, I notice that it will stay full. But if I leave it there and I don't add any water in, at 1 p.m., I would say it's about 3/4 full. And then time passes, I go for lunch, I have a little jog, I come back at 4 p.m., and I estimate that it's about 1/8 full. Okay, so these are just some notes that I've created. Now this is what actually I want you to copy down in your notebook. So when I look at your notes, I would see this question. Find the volume of the cone at noon, 1 p.m., and 4 p.m. I would want to see this image and these notes. Let's go over what we're going to do. I'm going to find the volume of the cone at 1 p.m. And I'm going to ask that on your own, you find the volume of the cone at noon and at 4 p.m. in this space. So I'm going to go ahead and start on our first one. The first thing I need to do is notice that I'm looking for the volume. Now the volume of a cone is the area of the base times the height divided by 3. I'm going to find the volume of the whole cone when it's filled up all the way. Every single piece is filled in. Kind of messed up my drawing here, but I'm going to imagine this is full of water, and I'm going to find the full capacity of the cone. So I'll go ahead and get started. Step 1. The volume of the cone starts with the area of the base. And again, my base, even though it's flipped over, is a circle. So I'm looking at pi times radius squared. That means I have 36 pi inches squared that can fit into the area of the base. My second step is to plug my values into the formula. That would be the area of the base times the height. The height is not given, divided by 3. What is the height? Now, before you say 10 inches, we have a big question to ask here. Is 10 inches the height? I hope you're saying no. It's not. 10 inches is the slant height. So how do I find this measurement right here? Well, this is a little tricky, especially given the way that I drew the radius. But I hope you remember from the reminder of your vocabulary how you can see the relationship of the slant height, the height, and this length right here. So let's kind of draw a closer look. They gave you the slant height, which is 10 inches. I'm looking for the height, and I know that from the height to the edge of the slant height, that would be the radius, which is 6 inches. Could you find the height? Sure you could. Use the Pythagorean theorem. H squared plus 6 squared equals 10 squared. That's 36 and 100 for my squared values. H squared is approximately 64. Well, it's exactly 64. h is 8 inches. Now I have my true height, and I can label that in my diagram as 8 inches. That's kind of hard to see. Let me make it blue. 8 inches. All right, now I'm ready to do my math. So I have 36 and 8. Those values I can multiply together. Let me get back to my green pen. And I get 288 pi inches cubed divided by 3. So now my question is, can I reduce 288 and 3? And the answer is 288 divided by 3? There's a quick check. Take these digits and add them together. 8 plus 8 is 16, and then add the 2, 17, 18. Since 18 is divisible by 3, that means 288 is 2. So when I divide that, I actually get 96 pi inches cubed. So the volume is 96 pi inches cubed. Now the question is how am I going to find the volume at 1 p.m. and 4 p.m.? So let's review our question. In the notes I said that at 12 p.m. it was full, at 1 p.m. it was 3/4 full, and at 4 p.m. it was 1/8 full. I'm looking for how much water was inside the cone at 1 p.m. I'm going to need a little bit of space. I'm going to go ahead and move this value over, or move this image over. Let's check this out. When it was full, it was 96 pi inches cubed. But I need 3/4 of this amount. So how do I find 3/4 of 96 pi inches squared? Well, it's just a matter of finding 3/4 of 96 pi inches cubed. All I need to do is multiply. Now, I have 3 times 96. Now, you should know that is 288, right? Because we divided. So I'm going to get 288 pi inches cubed, and I'll see if I can divide that by 4. Well, this is easy. 28 divided by 4 is 7, and 8 divided by 4 is 2. So how much water was inside the cone at 1 p.m.? At 1 p.m., there were 72 pi inches cubed. Now, when you find your 4 p.m. value, clearly it should be a number smaller than 96 pi inches cubed and smaller than 72 pi inches cubed. Good luck.